What is half of 4? 2. What's 2 squared? So now we're going to get 8y minus 8 on the other side. Now, the generic form has quantity x minus h squared equals 4p quantity y minus k. So what do I have to take out of that to get a parentheses going? 8. So I get x plus 2 quantity squared equals 8, y minus 1. So where's your h and k? Negative 2 and 1. So my hk is at negative 2 and 1. I have a p-value then of 2. Yes, sir?
Could you subtract 8y from, or no, add 8y to both sides and keep the negative 12 over and then just divide everything by 8? And then
Wait a second, how do you do that?
just add 8y to the side
Yeah.
and then divide everything by 8. And then you get x squared over 8 equals x over 2 plus 3 halves. And then just go from there.
In this case, you're not wrong, but in this case, I want you guys to use this format because when you use that one, you can't find your focus and your directrix. You're not wrong, Trev, because what you did, you still graphed the parabola, but I'm going to ask you to find the focus and the directrix. And that format, that standard format, doesn't give you that. Does that make sense? So what you did wasn't wrong, but it's not right. Yes, ma'am.
How do you get p equals 2?
8 is playing the role of 4p.
And when it's y squared, is it still, that's 4p?
Yeah, and it's just left and right. So this one would open upward.
Because it's x squared equals 4py and y squared equals 4py?
There's your center. P-value is up 2. Directrix is down 2. And go from there. You guys can write that out, right? This is kind of like everything. If you start thinking about it, I mean, really, there's no word problems. We haven't done a single one of them. Because the word problem that's in here talks about like the whisper dish. You know when you ever go to the museums, you can whisper, and that's a problem. Yeah. It's if you put them both behind you, you can have dual parabolas, which is technically like an ellipse as you go through. But that's just it's the idea of where do you have to be standing at to get, where do you have to hit the focus to be able to hear something is what you're talking. It's not difficult, but there's like one word problem in this whole chapter, and this is the one thing I don't, because and this was brought up 12th hour about the whole idea of a lot of these problems that I give you guys, I look to try to find some sort of an application, like what can you use that for? Well, what the idea is, you're applying what A, B, and C is every time. You're figuring out, if I gave you ordered pairs of foci and a vertex, you're figuring out, all right, that means A, B, and C have to equal this, and I can apply that to creating the equation. That's kind of what you're being able to do. And you've done that. You did that all right. So this shouldn't be difficult. No, we're just going to do something new. I don't know who's first.
I don't know either. Someone else can go.
Is 59 a circle? And if so, how do you graph it?
Yes, it is.
But how do you graph it?
How do you graph 55? Well, if it's, wait, no, I think this is before this is in here. Because if 6 is A and 6 is B, then it's just 6, right?
I got the equation, and then I confused myself.
Wait, so then for 61, would it be the direction to be y equals negative 1?
Sorry, hold on.
Maddie, what did you get for the directrix 61?
So you got x minus 6, 20 squared, 36, 36. So this is the standard form of a circle. You have a circle who's centered at 6, 6 with a radius of 6. So here's what you do. There's your center. And all you have to do is go up 6, down 6, left 6, right 6. Now let's see how close I am to making my circle. That's a square. That's pretty close. And there's your circle. That's all I gotta do, man. There's nothing crazy to this for circles. They're in a roundabout way, they're not terrible. Okay. Yes, ma'am.
For some of the ellipses and hyperbolas that we did, when we are like moving it around, so then like the x and y terms are together.
Yeah.
If you have like a negative term, do you factor out the negative?
Yes, absolutely. Which one was that? That was 53,
because that
right?
happened a couple times.
I think it only happens at 53. Oh, 57 it does too.
And I didn't know
Yes.
whether or not to like
Yeah.
just like leave the negative
That's-
and then factor out.
No,
what the
because remember,
negative was.
when you complete the square, what's your first term have to be? Positive 1.
Oh.
All right. So that's kind of like the one kicker of anything here where you guys will screw up, is that your only rule for completing the square is that your first term has to be a positive 1.
So that's not really what I meant. What I meant was like doing like this, or just like putting the parentheses around like this, and then like leaving a minus sign there.
As long as you factored it out, yes, that's fine. That's what you did.
Because what I did was I did it this way, and then I did it the other way, and then I was like, wait, but those are the same. Like, I mean, like 16 over 192 is something, and it's like the same. It's like both times 3. It's 12. So then it's like 4 times 3 is 12, and then 64 times 3 is 192. Okay, this is what happened when I just.
Let me finish. Let me do this one because I think I see where you're messing up here. So I don't think your final terms are right. So I don't have to complete the square here. I just know it's going to be a 16x squared. Here I have to take out the negative 1, and I get y squared minus 16y plus blank equals 128 minus 1 times something that we figured out here. 64, good. So you're going to get 16x squared minus 1, y minus 8 quantity squared, 64 here, 64 there, here is 64, there is 64, everywhere is 64. And you divide by 64.
Oh, you multiply times negative.
Did you accidentally, because you have 192, did you
I know, but then I did it. But then I did it this way too. But then I got x squared over 12 minus y minus 8 squared over 192, and then I got this answer that you're about to get.
It's x squared over 4.
Yeah. But then I figured out, isn't it like kind of the same, because 64 times 3 is 192, and then 4 times 3 is 12.
But here's the problem. What happens is, this fraction you had here was what, 16 over,
192.
what does that fraction simplify to?
And 1 over, I got 1 over 12.
It might be. If it's 1 over 12, that now tells you that your a squared value is 12 and your b squared value is 192.
That's why.
And that's not the same as what this is. This is what it's supposed to be. Okay?
Yeah.
And I think the reason that you might have messed that up is when you added to the other side, you forgot that there was a -1 scalar right there. I have a feeling that's probably what you forgot. That's how you got. I think that's how you got 192.
What I did, yeah, but because I didn't know whether or not. Because what I did was I just put like the parentheses around that part.
Yeah.
And then the parentheses around the x squared, and just left the negative
Yeah.
like in the middle.
You have to factor, and that's where it is. You have to factor out the negative. So you factor out the negative, and then you make sure whatever you factor out, you have to send to the other side, whether it's a +3 or a -6, whatever. It's got to go to the other side also. That's how you got 192.
That's why I did it both ways, because I didn't know what to do.
Well, do it this way, and you'll be all right.
Okay. I think I graphed it.
Do you guys want me to finish graphing that at all, or are we okay graphing the height?
Wait, would it be up and down?
This is x squared, so x squared goes left and right.
Wait, which one? What's the thing looks like it's great if A is greater?
That's for
the
ellipses.
ellipse.
Now remember, you should never get that wrong because you can always reference your calculator to figure that out.
Oh yeah.
But wait, you told us that both hyperbole and ellipse, that A is always bigger than B.
Because b here is negative. We don't talk about it that much, but I think that works. Just won't get any signs.
Yeah, hyperbole and gang sign.
That's the one.
I don't have it here.
Did I graph it?
I don't know. Would you like me to graph it? Because you went, your vertex was A short, B's longer. Yeah, I think you're saying that's true.
I did it.
What else you want to look at? I have a couple extra problems that I ran off. I have stuff on. This isn't
Mr. Murphy, can we try to make the test tomorrow so I can study from it?
whatever.
What does that mean? That means yes or whatever, because I never know if that means yes or no. So I'm gonna like. Is this just like all chapter 1?
Yeah, that's about it. Now, what I've done here with the 10 stuff is that I want you guys to be able to. There's a lot, but you know, all I mean, because we've done basically everything that I have in the book. So remember what happens here. If you think about how we started this stuff out, we started out real slow, just kind of showing what everything meant. I mean, really, we just showed what all the different parts meant and worked out of that. After we did that, that's when we started just moving stuff into space. So we quite literally took our own sweet time to get through most of this. And that's the point. Yes, ma'am? There might be. Yes, sir. What's that? Oh, the intersections? Not today. I was gonna do that beforehand. I'm gonna do that tomorrow. So, a couple things that are thrown on here. If you think about what we did in 10. Oh, did I not have enough? Sorry. Yes, sir. I didn't get one. I'll get you one.
Okay, I'll look at it.
We learned all that?
Yeah. Oh yeah, we did all this stuff, guys. We did all this stuff where we worked through So what happens here is that we went through the basics of everything and just started talking about what did all these different shapes look like as we went through without any of the shift to it. And then we just kind of put everything together with the shift. Now, the only thing that I was trying to go through on this little thing I just made out of CUDA real quick, it's just extra problems. That's really all there are. Now, really what you have to remember here is that in order to excuse me, in order to be able to do any of this stuff, you have to know what things mean. And that's the idea. As long as you know what your A, B, C stands for, what P means, it's the opposite of P, everything else falls into play. Because I'm not going to take the formulas away from you. Okay? You're going to have formulas. That's not going to be an issue. It's just a matter of, are you going to be, do you remember what things mean? If you do that, you're fine. It's really, really straightforward. Now, the one things that I threw onto this thing real quick were that vertex, photex. Yeah, that's a new term. It's called the photex. It's like faux leather, so it's the photex. It's like the text you almost sent, but you didn't. I have no idea what I'm talking about. Go figure. So you've done this stuff. I mean, these are written in the vertex form. So this stuff you didn't see. I didn't realize it printed it that way. That's the easy way. So I would basically start looking at, can you write the equation given a vertex and a focus? Can you write the equation center and radius? I mean, can you write the equation given the center and the radius? I mean, how is that? There isn't any, I couldn't find anything about the tangent line, so we can pull up the tangent line here in a second, so you're asking about that. Can you graph, identify center vertices, covertices, and foci of different types of conic sections? These are obviously going to be ellipses because of the plus sign between the two. Write the standard form of the conic given vertices and foci.
When we are given vertices and foci, are we supposed to find the covertices?
No, you don't need to.
Okay, because I don't know.
Okay, good question. When you're given something like this, let's look at number 11. And it says it's an ellipse, so we know it's going to be an ellipse. When you're given this information, what you have to be able to do is identify the stuff you need to find. Well, I need to, first of all, knowing that it's an ellipse, I have to decide whether or not it's going to be a vertical or a horizontal ellipse to determine which equation to use. So I graph it. 9, negative 9. Negative 3, negative 9. Which means, which way is this opening? Left and right. If my vertices are across from one another, that means it's going to be doing this. So it's in a left-right ellipse. So that means I need to work with an x minus h quantity squared over a squared plus y minus k quantity squared over b squared to equal 1. Yes, sir?
Isn't that a hyperbole?
It said in the problem it's an ellipse.
Which one are you doing?
They all.
3, 4, 7. I don't remember. Sure. Okay. So as I go through that, we know our vertices are here and here. Well, what happens in between? Right in the middle is going to be your center. So what is 9 plus negative 3? What's half of that? 3. So our center is going to be at our HK at 3 and negative 9. So you know that much now. Now you also know that the distance from the center to the vertex is your A value. Well, that's going to be 6. It also tells you that the distance from the center to the foci is going to be the square root of 11. Because notice, your center is at 3, and you're adding root 11 to it. You're subtracting root 11 to it. So your C value is the square root of 11. Yes, ma'am?
How do you know H and K are 3, negative 9? You just took it from the vertices.
Yeah, I just, because the center is always at the midpoint. That's it.
But wouldn't it be negative 3 and then 9?
So, because it's the distance from the
It will be when I just saying H and K are 3, negative 9. So when I put it in, it'll be x minus 3 and it'll be y plus 9. It will be that when we're done. Okay. So now it's an ellipse. Ellipses, do they have the plus between for the a squared, b squared, or minus between?
Minus.
They have the minus between, so we just figure it out. So we write c squared is going to be a squared minus b squared. So 11 equals 36 minus what? 25.
That's what.
Voila. And that's French for voila. Nope. We don't have to label it. We don't have to print it. We don't have to graph it. We're using what we are given to find it out. I mean, we could find the covertices, but we don't need it. All it asks me to do is write the equation. That's it.
Do you remember that one homework problem that was really hard, that none of us understood, that you said we should expect on the test?
Yeah, the
I don't
complex,
remember what it is.
complex fraction, it was like 1/9.
Do you mean all of those?
No, it was like one that I don't remember, but it was really, really
I
hard.
remember it. It was 1/9.
Oh,
over
you have to do the
1/9.
complex fraction on
Can you
that?
go over that?
Is that going to be in the class?
I don't know.
Yes.
Oh my god.
What is it?
Which one was that?
I don't remember. I don't remember. I just remember
It was
there being
1/9. It was 1/9 over 1/9.
and saying that we should.
Yeah, it was a 1/9 thing. It was a really weird scenario. Which one? I'm trying to think what that was.
Oh, so we were using divide fraction, divide fraction.
Yeah.
Nice catch, Maddie.
Oh, it was 42 on page 619.
Oh yeah.
Is there going to be something like that?
I don't know.
Please go over.
So this is the one we had to do. So you went from there.
Oh yeah, that's it.
So really, the only thing you have to remember is if you get something like this, what you're getting, you multiply everything by whatever this is, its reciprocal, over its reciprocal. Now watch what happens. If you go long form with that, you get 1/9 over 1/9 times x squared over 25 minus 1/9 over 1/9 times 9y squared over 1 divided by 25 over 1 equals 1. Because this is still going to be 1. Okay.
Why can't you just do 1/9 over that? And like, what if you do 1/9 divided by 1?
Because I just do 1/9, it messes
Oh,
everything.
so then you would mess up that.
Right. Because all these are factors of 1. This doesn't change anything. You get x squared over 25. This is how when you multiply in, you get y squared over 25 over 9. So you might notice that kind of the shortcut of this is,
Wait, why didn't the other one change? Why didn't the other do that?
what's 1/9 divided by 1? 1. That's the reason I can do that. That's all. And it's quite literally flipping it. Well, then you can graph. Well, what's your a squared? What's your b squared? Which way is it switched? And even though it's a fraction, I mean, it's 25 over 9. So that your b squared is 25 over 9. Your b value is 5/3. So it's not. It's crazy, but it's not terrible. Okay. So Maddie, you'll notice that the trick was just bring it to.
Yeah, I wrote that down.
So that's it. That's all it is. Okay. You guys were saying something about circle with a tangent, right? I'm almost done with it.
Do you make a new test every year?
Yeah. Why? Well, it's not just that. It's
My
just
brother has every single test.
it's just that I teach things a little bit differently. I emphasize other parts. There are some things like last year we did intersection of the conics. I haven't gotten to it yet, and don't know if I need to, I don't think I would do it enough justice in one straight day to find the overlaps of those things, like shaded region. So that's why I'm like, I'll wait and do that like tomorrow, or sorry, maybe Friday, we'll do that maybe Friday, Monday, and then, I don't know, maybe we'll do that along with the shaded regions of parabolas too, just kind of mind that as a short quiz before next week. Let's test, we'll do it all out. So this one was write the equation of the line that is tangent to the circle at a specific point. So, excuse me, if I want to write the equation of the line that is tangent to a circle at a specific point, what I need to do is basically find slopes. So this one here, you're centered at the origin. I have a radius of the square root of 40. I really don't care about that because what I'm looking at is I want to be at the point, was it -2 and 6. My circle, well, it's something like that. It's more of a potato, but squint, it'll be all right. We want to find the equation of the line that is tangent to the circle through that point.
Wait, what number is this?
It's 40 in the circle section. So what we need to do is we have to find the slope between these two values. Rise over run. I went up 6, left 2. So my slope here is -3. -3. Tangent is when it touches it at the circle at one spot and it's going to be perpendicular. So the opposite reciprocal slope would be 1/3. And what point do I want to write it through? Right through that.
Wait, what is
It's the radius.
Oh.
It doesn't matter.
How's 40 the radius?
Well, I'm sorry, the radius squared, so it's the square root of 40. So the radius is 2 root 10. That's much cleaner.
Are you going to put questions that are
Do you need to be at the origin?
Yes, please.
You don't need to be at the origin. Because all you have to do is figure out that all you're doing is finding slopes. So if you're finding the slopes, you find the slope between 2 points. And then you just substitute through. So you get y minus 6 is 1/3, x plus 2/3. Add 6 to that, you get 20/3. And that'll be your answer.
Can you go back to number 11? Wait, is it, so you just draw the point that's like tangent?
Yeah.
And then,
So it's find slope, perpendicular, goes through there.
oh.
Should be. We're saying
Will you tell us to find like the perpendicular slope and all that?
no, I would say write the equation of the line that's tangent to circle at a specific point.
Okay. Well, yeah, that's fine.
Wait, did you?
Yeah,
did
I
you
would say
finish it?
that.
Did you finish it in y-intercept form?
Yeah. Yes, ma'am.
What was the point of 40 and
Nothing. Because it gave you the equation of the circle. And they're saying write the equation of the line that's tangent to the given circle at a specific point. So it just gave you the equation of the circle. That's it. Say your.
Oh, this is what we were doing before. I don't know the circle, the equation of a circle. I was like, no, you can go back.
There are a couple other on here. Well, don't worry about these two because you can't find the focus out of those. It was, yeah, I actually used this review last year because I did a little bit of parabola stuff at the beginning. So 1 and 2 you don't worry about. Remember your p-value is the distance from your center to your focus. Well, so what's your p-value here? Your vertex is at 3, your focus is at 3 and 1/8. What's your p-value? 1/8. Go from that. Let's see the rest of these things through here. Vertices, blah blah blah. Hyperbola stuff, pretty quick. Identify the conic section, standard blah 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 graph. Fun. The last 4, don't worry about solving systems of the equations. You have not done that yet. We'll get to that probably Friday.
Everyone in like algebra like word out, and she was like always saying, "What are you guys doing? We're solving system equations."
Well, they're doing the systems equation that we did like the 2nd, 3rd week of school.
Yeah. They're like,
Wait, so
they
don't
still
worry
said they were
about
on
those?
chapter 2, and I was like,
Yeah, we're a little bit. We bounce around.
So don't worry about.
Yeah, we haven't done it yet.
wait,
So.
can you go back to work for number 11? Because
I got it. Where did you get C is square root of 11? I guess
from the book. Oh,
Yeah, because what they gave us here was your foci was at. We knew that our center was at. We figured out that our center was at 3.9. So then our focus they said was at 3 plus the square root of 11, and 3 minus the square root of 11. So the distance from here to here is your C value. So we just interpreted it from the given ordered pairs. It's really nice when they give it to you with the square roots like that, because you're really hard pressed to figure out. Well, there's your distance, square root of 11. Yes, ma'am.
For the tangent thing that we were just doing,
Yeah.
you have to use the perpendicular slope.
Yes, because tangents form right angles. That's how you do it. Yeah, tangent slopes are opposite reciprocals. If you want to be rambunctious and whatnot, I do believe that I have.